let's enjoy. We'll keep going. There is no stopping. Okay. Now we are at chapter 5 out of 9. Okay. We've already passed half now. We are passing half. If we go through this chapter, we've gone through more than half of your paper. How amazing is that? That's a fantastic thing. Let's quickly go through this. We're not wasting any time. Okay. Time is of the essence. So remember that this is going to be integration 2. That is the topic number 5. So we call 3.5.2. Or 3.5 rather. We just put 3.5 and it's going to be integration. That's how you spell integration. Okay, you can just look at the formula there, the spelling there. Integration 2, that is going to be what we are covering in here. We would have done integration 1. We have done integration 1 in paper 1. Now we're going through integration 2. It's a walk in the park again. We are not going to cry. We don't cry over this. This is basic for us. I know that you know that. Let's go through how many subtopics do we have? 1, 2, 3, 4, 5, 6. We have 6 subtopics. Let's see the subtopics, okay? The first one, you can see here, they say, extend the idea of reverse integration to this guy, this guy, this guy, this guy, this guy. What are these? These are called common integrals, okay? We've seen common derivatives. Now, these are called common integrals. So the first thing, 3.5.1, is going to be common integrals, okay? We must know common integrals. We must be able to integrate those guys, okay? Common integrals, we must be able to integrate them. How many are they? There are 6. So you can have them 6 guys, okay? You can say 6 guys. You must be able to know what you get when you integrate all of them, all 6 of them. Then let's go to 3.5.2, okay? And you see, some of these integrals are going to be very easy because we are going to be using the common derivatives table to do the integrals again. So very simple. Okay, now let's go to this second one, 3.5.2. What is it about now? So let's see, what is this? It said use trigonometrical relationships in carrying out integration. These are called trig integrals. So trigonometric integrals, if you want in full, but in short we can just say trig integrals, okay, which is trigonometric integrals. We're going to be dealing with trigonometric integrals. What are trigonometric integrals? It is when you use relationships of trig to integrate. There are certain guys that when you're integrating them, you have to use things you learned in trig, okay? That is why you must master those compound angle formulae. We'll go back to it. It's fine, but that is your chapter 3. So anyway, let's see the next thing now. 3.5.3. What is it about? 3.5.3. This is integrate rational functions by decomposition into partial fractions. So this is going to be, we are integrating by decomposition into partial fractions. So we can say integration by partial fractions. So we are going to see there are certain guys that we can only integrate by using decomposition into partial fractions. So what do you mean by this? First, we decompose a fraction using the idea of partial fractions. Then once we have done that, we can now integrate it. So there are things that you have to do that. Partial fractions is a way of decomposing. You'll be breaking down the denominator of guys and you make 2 new functions, 2 new fractions. And then we are going to integrate those guys and we can be able to find. So we are going to do common integrals, then trig integrals, then integration by partial fractions, okay, by decomposition into, if you want to put, by decomposition into partial fractions, okay? Decomposition into partial fractions. Then we're going to have 3.5.4. What is this other way now in 3.5.4? They're saying recognize an integrand of the form this and integrate such. This is going to be called integration by U sub or by algebraic sub, okay? By algebraic sub, okay? That is, or you can put in brackets to say U sub. But U sub is also there in the last one, so I don't want you to be confused. This is by algebraic sub, where you have the derivative being on top and the function at the bottom. We'll work on those. I'll show you. Don't worry, but just put that. That is going to be one of the things you must know. So these are methods that we're going to be doing. First is common integrals. You must be able to know some integrals that you just know, okay, that are just known. Then you must be able to know things that we integrate by using trigonometric relationships, okay? Then you must be able to know things that we integrate by decomposing into partial fractions. Then you must be able to know things which we integrate by algebraic sub, okay? Then if you go to 3.5.5 now, 3.5.5, they're saying recognize when an integrand can be usefully regarded as a product. So this is going to be integration by parts, okay? We're going to do integration by parts. That is going to be T.5.5. Integration by parts. So you must also know when you use this method. So these are just methods of integration. Nothing else. These are just methods of integration. And now let's look at the sixth one, the sixth method of integration, and the final one. What is it? Use a given substitution to evaluate either a definite or an indefinite integral, e.g. u is equal to sine x. This is called trig sub. So you can say integration by trig sub. So you can say integration, they'll give you, don't worry, you can say integration by trig substitution. This is not hard, because every time you use a certain method, you'll be having a certain situation. So you must know, okay, when I have this and this, I use this method. When I have this and this, I use this method. Integration is not even hard, people. Integration is not even hard. It's one of the things you want to master. You want to master it. Remember, when you go even higher, you're going to have more things. But this is the beginning of it. How beautiful this is. This is going to be our integration. We have these 6 parts and you will be done. All right, now let's get into work. Let's get into integration. Let's get into it. Goodbye for now. I'll meet you inside.